You got to have a little bit of fun,
Thanks for
right?
all
Nice,
your help.
nice.
Say it again, Frank.
Well, I was just thanking Ronnie for all her assistance along the way.
Yeah, Ronnie, Frank is here.
Hi,
I
Frank. It's
made
nice to
it.
finally meet you.
Likewise.
Nice. Let's see, where are we in time? We got a minute or so. Frank, you have to join, and Jack, maybe you could join too. The next fireside chat. That was really fun. We had seven attending that one as our first fireside
Mhm.
chat. So kind of really open ended, no script, just asking questions and talking about um, here's a topic, so let's kind of stay within the topic, but otherwise let's you know it's an opportunity for people in the community to just kind of get to know each other and ask questions and compare war stories. So that was really neat. I enjoyed that.
Yeah, absolutely. I'll try to make the next one.
We're about 12:01, so I say let's go for it. I want to just expand a little bit on Jack. Jack and I met a little over a year ago at Dig South, which is a digital conference here in Charleston that happens. Let's see, when is that? It's in the summer because I remember it being very, very hot. So, and Jack has also been um, very helpful in some pivoting that we've been doing within our business. He serves as one of our five advisory board members for Concentric Global. So, Jack, I really appreciate you collaborating with us on the Lunch and Learn. The number one buzzword and kind of the sought after standard that was brought up, and the topic that seemed to resonate the most with attendees at the World Conference on Quality and Improvement that ASQ and Exempla Global put on down in Orlando this year was AI. I mean, everybody was talking about AI and how do we, put some rails on this thing? How do we use it? Yes, but what is responsible use? So, um, between my experience there, my experiences thus far in working with Jack and looking at AI governance really now surfacing. It's been out for a few years, but really picking up some steam with the ISO 42001 2023 version, which is the first edition. I thought it was a great time to address kind of both sides of the same coin. So today we're going to be talking about, and Jack's going to take most of the time here, but AI integration plus those rails and controls that ISO 42001 brings. And what we're going to do is walk through. This one is very slide heavy, so we're going to try to be mindful of time. Bodo, Ronnie, if you could kind of help keep us on track. There'll be some slides we'll just have to kind of bang through, but we'll be happy to provide the recording and the PDF of the slide deck after the class. So, um, Professor Jack comes with a lot of accolades, 12 years of experience in this space. And he's going to walk us through uh, really a case study of AI, the opportunity not only in compliance, but let's use this through the lens of, say, a manufacturing sector, different use cases, and that sort of thing. So, without further ado, let me advance the slide. So, a little bit of uh, logistics here. So, Jack has provided a slide deck uh, really focused mainly on AI and his lens. And then what I've done is created an overlay on top of that. And so I'll explain that here in a bit. But Jack, why don't you kick it off by kind of setting the stage on this ground floor and what you'll be presenting?
Totally. So what we're talking about here, and thanks for the great introduction, James. It's been a pleasure working together for a while here, and
Yes,
so
sir. You
great to
bet.
meet a few other folks that you're working with here. I see we got a good number of people on the call today, which is great. Okay, so basically, like James said, I've been working deploying AI for like a dozen years. Former professor, I used to teach a PhD course on how to apply AI and machine learning in industry. I've been working specifically with manufacturers applying AI, especially focused for the past little while now. And this talk kind of focuses on where is AI used in manufacturing and how can it be used in the different pieces that make up the manufacturing life cycle, all the way from sales and client acquisition all the way through production and ending with customer service. Because really you can fit different AI tools and techniques in to get serious value at every step along the way. And just knowing what those steps are, how AI can fit in, and seeing some use cases of how other companies have done that can be really helpful. And then what James has added in here is some really awesome lens. Just sticking an AI model into into a manufacturing system often isn't good enough. You need that compliance framework to be able to say this model is reliable, it's safe, it's going to work the way we intend it to work. And that's where this ISO 42001 framework comes into play. And so I think James has done a great job of adding little snippets of how these different AI models and systems, now that we see how they can be integrated into manufacturing, how can they be audited? How can they be compliant? How can we be confident in the results and security of the systems we're putting into place as we get those efficiency gains? Does that do a good job, James? I feel like we're going to be
Yeah.
tag team.
You're good.
But,
And so, in just kind of lay of the land here. So, whenever you see this guy and this our little character here, we're going to call him AIMS, which is uh, AI Management Systems. That's the abbreviation for this standard. Anyway, so we're going to call this guy AIMS. And so, what AIMS is going to do is he is going to be an overlay uh, to Jack's presentation, really two lenses, one shop floor. What can AI do? So that's kind of Jack's piece, and you'll see that kind of in the regular font, and then the pop-ups or the call-outs. How do you deploy it responsibly per 42,001 2023? So aims here, we'll just jump in, and I will be what's it called when human is being the augmentation for AI. It's kind of the reverse, but that's what we'll do. That's what I will do is represent aims and kind of that interweaving uh, of the controls within 42,001. So
all right, let's kick
that's
it off.
that's the cadence.
Okay, we probably aren't going to get to the hands-on demo today in this time, but I think we can skip ahead
Okay.
with this. I think we can go ahead and skip that.
No,
This, you
we no.
guys,
Yeah, there you
you
go.
guys heard the intro for me a little bit. Like I said, 12 years deploying AI in computer vision industry, former adjunct professor, working a good bit with manufacturing systems right now, doing all sorts of different stuff. Um, Especially locally, working with folks in South Carolina, but really all over the world. We work with manufacturers abroad in Scotland and over on the West Coast. So yeah, there we go. That's my family, my
There's
dog,
your family,
my guitar,
dog,
all things
guitar.
important to me.
The tough day
That's
of
right.
at the office down here.
That's right.
Checking the box, getting the work done. Very cool. Awesome. That's my favorite part is kind of learning about who's who and what's what, and a little bit about where you come from and who you surround yourself with outside of work.
Okay. All right. What is AI? Usually we stop here, and I like to open it up to the folks on the call. Does anybody want to proffer a definition of AI? What is AI?
What is it? Anybody want to throw it out there?
Don't be shy. Just jump in.
Inevitable.
Inevitable.
Yeah.
Good
In a word.
description, although I don't know if I would call that a definition.
Well, it's artificial.
Okay.
It's not so it's a great path for the future.
Okay.
For everything
Cool.
we do.
I love it. Anybody else?
Yeah, I just want to chime in here. Most of the people that I've been talking to have been saying, oh, AI this and AI that. And you can substitute that with what we heard back in the 80s. Oh, computer will know, computer will know. What I found, I've been doing a little bit of playing around with ChatGPT and Claude and Gemini and the Google AI. And what I'm finding is it's not the true AI. I took engineering in at McMaster University, and some of these people that were working
Mm,
on AI in the 70s and 80s uh, had it so that the it was actually learning something from this seed program that they had. But what I'm finding with all these programs online is it's not even close to that. What I'm finding these programs that the general public has access to is it just is a little bit faster than a computer of history will look at all of the data and summarize it very quickly and very easily. So to me, it's no more than a program.
mm.
Yeah,
But
I
you
love
know,
that. That is actually such a great lead into what we're going to be talking. You want to go to the next slide,
Sure.
James? This is kind of my answer. So it's very hard to talk about AI. Well, it should be harder to talk about AI without being able to define really what it is and how it relates to other fields of software. A lot of people are using this term throwing out AI, and in today's parlance, often what it means is just ChatGPT. But AI is so much more than that. As Donna was saying, AI has been around since the 50s, is when AI started in one form or another. And it's changed and evolved a lot since then. And even since I've been working in AI for the past decade, it's changed and evolved quite a lot.
Mhm.
So, to talk about what is AI, I like to start further out. And let's just say, what is computer programming? So computer programming is telling the computer step by step what to do. You're giving it instructions, do thing one, then thing two, then thing three. And then it executes and you run a program. So now focusing in a little bit, what is AI in general? AI is you basically set up a set of rules for how a system works. If this, then that, a set of rules and constraints, and then you give the computer a piece of data and it makes a decision based on the rules that of the system you set up. So a little bit less step-by-step instructions, a little bit more, here's the rules that govern your decision making, go make a decision based on those. A step kind of deeper, machine learning is now, okay, what if we don't know the rules, but we have a bunch of data that gives us examples, right? If we're trying to predict one thing like the quality of a part and we have 1,000 examples of that part in various states of quality, can we build a system without us saying, okay, look here and then look here and then look here, or look at these factors? Can we have the AI decide what stuff to look at? So machine learning is when you feed in a set of data with specified values in that data, specified data points and an outcome, and then the algorithm learns how to take that input data and predict the outcome you want, such that when you feed in a new data point without an outcome already labeled, it can give you that label. Deep learning, very similar to machine learning, but it abstracts at one more point. What if we have so much data that we actually don't know what parts of the data are important? Can we have the algorithm take this large data set and say, okay, these are the pieces of data that are important. Then I'm going to learn the rules from this data. Then I'm going to be able to apply those rules to new data. And that's what deep learning is. Generative AI, aka large language models, LLMs, things like ChatGPT, Gemini, Claude, are all a specific subset of this deep learning where it is a pattern continuation, right? So it's built to operate on text, where basically all it does is you feed in a sentence and it tries to predict what's the next word. And then it predicts the most likely next word, tacks that onto the sentence, looks at the full sentence again with the new predicted word, and says, okay, what's the next word? And then what's the next thing? What's the next thing? It's autoregressive. So that's what generative AI does, is it's able to generate these sequences just by processing one sequence and then trying to continue it on. So in general, when we're talking about AI for the purposes of this talk, AI is just a piece of software that learns patterns from examples. It's not programmed with hard and fast rules or hard and fast steps. It's a learning system.
learns patterns. All right.
Let's keep it going.
And the yin to the yang is you learn from examples, then your examples are the product. So that's Ames's way of tying in, which is Annex A, and it's point A.7 data. The product and the controls become the examples that the patterns are learned from. So just tying those in. And Jack, just like the statement about, what is AI and how difficult it is to define that. It's very difficult to define, well, what is a management system? And in this particular case, you have ISO 9000, 42001, that is a standard for controlling the integration of AI within the way that you manage your business. So it's the rails, it's the, we don't want to stifle creativity, but there needs to be kind of a tight governance, so that you're integrating AI and you're using it in a way that's responsible. So this is a good example, just an illustration. This is something that we'll give to you. We'll post in our community. This is what we call a quick reference guide. So this is really the layout of 9001. This is the layout of 27,001, 42,001, 45,001. You have this kind of planning, do, check, act, and different controls that all follow this high level structure. Now, I like an illustration like this because one of the things I'm able to use this for if I'm auditing or designing systems or doing an assessment is, okay, where is the part of the standard that talks about, let's say, operational controls, or if there's a problem with AI, how do I correct it? Who is responsible for what as it relates to AI integration in the management system? And then you can see here, you have your normal Annex A here that's giving some further context. This standard actually has Annex A, B, C, and D. So it has a lot more supplemental information. And what you'll see is a lot of controls in Annex A that are meant to give further context to each of these clauses 4 through 10 here. So that's kind of the lay of the land in terms of what is 42,001, what are the components, how does it connect or relate to other management system standards. Now, this is pretty much the same thing as the last slide, just a different way of looking at it. And one of the things I wanted to point out here is, and we see this with environmental, health and safety, quality, we see this with these standards as well. Clause 8 mirrors Clause 6. So the idea here in Clause 6 is, how do you assess risk? How do you plan for risk? How do you identify those risks that exist within an AI system? And then how do you treat those risks? Are those risk controls successful? How do you monitor the risk controls to ensure if something goes wrong, let's say a part of your AI starts to allow a defect through, what do you do there? How do you pivot? What's the corresponding operational control to those lists of risk and opportunities that you are laying out in Clause 6? This is also helpful in just seeing how in-depth Annex A is. So this is a little bit confusing. Annex A is a little bit confusing because in these other management system standards, Annex A is guidelines, and there are no statements in the annex or in the normative reference in the guidance part of the standard that say you shall do this, the organization shall do this and that and this and that. In the 42,001 standard, shall exist all over Annex A. Going back a couple slides, you can see there are 38 controls that are applied in Annex A. The language of thou shall do ABC. It does exist in this standard. Now, there's a little bit of a loophole that says an organization can basically opt out of these if they justify, and you might have additional controls that aren't listed here. So it's a little bit confusing because it says thou shall do ABC, but there's a kind of an overarching rule that this is meant to just give examples of controls that could be deployed, not 100% prescriptive on these controls. So that's something that's a nuance that's quite different than the other management system standards. Back to you, Jack.
Okay, let's go right to the next slide here. AI manufacturing is climbing. There is a lot of different ways, and we'll go through how AI can actually help manufacturers, but just some quick stats here. Adoption is there, right? How you measure AI adoption varies a lot based on the study that you're looking at. What counts as AI, what counts as adoption. You can see all the different numbers here. Some studies put it at 30%, some studies put it closer to 80%. But there's a couple hard statistics that motivate AI usage, which are not as subjective. The workforce is getting older, right? 25% of the manufacturing workforce is over 55. Almost 80% of companies have indicated concern about their population aging out. We're expecting almost 4 million jobs needed by 2033. And 82% of manufacturers are expanding budgets related to AI. So there's a lot of need for this technology to address some fundamental problems we see in manufacturing, the manufacturing workforce these days.
Yep. So just a little addition here is depends how you define. So for example, just picking up on this. So depends how you define it is why claims must be measurable. So for example, in looking at these 4 sources of information, you're going to get, some difference and variation in what the actual statistic is. So the idea is, we need to define clearly what we're measuring and what makes these numbers, what makes these statistics reliable or not. And that's something that you see in clause 9.1.
Okay, so now what we're going to do is take a deeper dive into where AI can be used in the manufacturing lifecycle. And to do that, we are going to follow one hypothetical product from one hypothetical company. Our company, we're following Well Done Manufacturing, and the project is just a wishbone. A steel control arm is seen in a lot of vehicles. And we're going to go through each of these steps, which I'm sure you all are familiar with already, and just talk about a couple of quick places AI can be useful in those areas.
Yeah, and this mirrors 42001's AI lifecycle. It's a governance at each of these checkpoints, and that's something that you'll see guidance in Annex 8.6. But yeah, this is really the life cycle of this product or this value stream, and you need to have governance. If you have integration of AI at each of these points, that's where you have to have the controls, the checks, the validations, etc., checkpoints.
Okay, sales and lead gen, you guys are all familiar. We're finding prospects, we're qualifying clients, we're pursuing the bid. This is that kind of selling stage. Go ahead and move next.
Okay.
Now, what are the issues we see here? A lot of companies have too many leads, right? A lot of leads that are probably low quality are dumping into the pipeline. How do you chase those down? Or you have too few leads. You're not sure who wants to buy these products or where to find those folks. It can be tough to tell who's actually going to buy, right? People may express interest, but how do you know that's actually going to convert into a sale? Those are the folks you want to be spending time on, is the ones who convert, not the ones who don't. and good opportunities may slip through, right? You may just not have the bandwidth or resources to pursue an opportunity that would have been a good one because you were too busy chasing down the potentially lower value opportunities. And AI has a lot of help in these areas. It can automatically search the web for leads to help fill out your pipeline. It can mine data that you already own to surface intelligent leads, aka looking at past conversations, looking at past sales, looking at customer interactions, and then identifying, okay, these people look similar to the folks who've bought in the past. These are the ones that I should be pursuing. Auto enriching, these are things like, let's go out and scrape the clients or the prospects LinkedIn profile or do some research on the company and then automatically pull all of that into a brief or a CRM or anything that you would like to enrich those leads. And then giving direct scores and ranks, right? Putting a number on a lead. This is the likelihood that this is actually going to convert into a sale and, help you sort through things that way. And then on the next slide, we should have some examples around this.
Yeah, and I just to pause there for just a second. This was something that we bought into early on with Salesforce. Back in 2013, we bought licensing for not only the baseline software product, but also a feature where they said for the an extra $1,000 or something like that. We will give you all of these leads, and you will have 300 leads mined for you every month. And those leads, they oversold the effectiveness of that because it was a bunch of front desk telephone numbers, and at that time you had very few people still mining kind of the phone. When you called the main number, it'd take you to kind of an automated system. So they oversold, and the value of that really didn't pan out compared to what they actually sold to us. So but at the same time, Salesforce is leading a lot of back office processes, and within the last couple of years, me personally, I've actually invested. I'm on a drip campaign every week. I give an investment directly to Salesforce stock because I was disgruntled back in the day, but now they're doing some things that I think are innovative and will really improve the integrity of that mining and that lead gen piece. Anybody that's on LinkedIn or anybody that has an inbox, if you have any sort of business rep web presence, you're probably being inundated day in and day out with offerings from companies saying, we'll give you leads, and it's only $5,000 a month. And so there are a lot of offerings now. Some great, some not so great. So this brings up a point that Ames has here. To scraped lead data raises a couple of things: provenance and permitted use questions. So you need to really look at whose data are you taking? What is the integrity of that data? Are you violating any permission or privacy issues? Especially as you're doing and using information from one country or one region to the next.
Yeah, use cases. I really only want to talk about the first one here, as I want to keep an eye on the clock. Caterpillar, this is a very interesting study that they did. Basically, what they did is they put sensors on all of the moving land movers and whatnot machines that they're selling. And those sensors would report back to Caterpillar on this current state of the product. Was it deteriorating? Was it seeing use in any specific ways? Was it up due for a maintenance cycle? And what Caterpillar did is this data was massive. There are tons and tons of live sensor readings coming back to them. So they used AI to scrape through those and determine, okay, what services or maintenance sales can we make to help extend the lifetime of these products and provide value to the product owners? And when should we be reaching out to make those offers? And this went from $0 in 2021 to over $1 billion in 2024.
Wow.
I believe this year it's over $1.5 billion that they're making in this. So this kind of usage of taking their data and the information they have about their products, collecting that, processing it with AI, and then using that to drive a sales funnel, gave them over $1 billion in new revenue over 3 years, which is a large number. I think we can all agree.
And another aspect that's really interesting here is the ability to see what the market pull is going to be. So you don't have too much inventory sitting around, on the shelves or,
well,
we're going
to get to inventory management in a minute here.
Yep. Cool.
Definitely. That's definitely a real use though. That's more in that kind of plan and source phase. You have a customer who's interested. How do you estimate the cost? How do you read the specs and drawings? How do you respond quickly and accurately? I think there's a number, something like 60% of bids are won by the first one to submit a proposal. So being able to quote reliably and fast, and you want to make sure that at the end of the day, whatever price you quote, you're going to make money on also. So
yeah, responsiveness has been a massive attribute for us that's been positive, because we're really in a lot of our requests for quotes competing with the big guys. And so as a smaller team, speed, we have that edge, and we take advantage of that, and AI can help us and has helped us in this department. So
yeah. So again, what are the bottlenecks? How does AI help? Quoting is slow and manual, which leads to losing bids. Specs can be huge, right? Any sort of specs or standards that you have to reference, either from the client or from your own internal documentation, can be hundreds of pages long. And institutional knowledge can be buried or stuck in the heads of people. It can be hard to, get the whole team together, get everybody on the same page and put this quote out there. AI can help with that immensely, right? Drawings and specs, it can read these instantly and answer questions directly about them, or read through your quote and make sure it's referencing the right standards. You're not forgetting about anything. Adding in a persistent knowledge layer that kind of collects all the data running through your shop, puts it in one place, and then allows an AI lens to interact with that data dynamically, means that you can answer plain language questions about manuals, SOPs, past jobs. You can look at old quotes and use that to inform how new quotes should work. You can look at which old quotes won money versus actually made money versus lost money, and use that to adjust your bidding strategy. You can auto draft responses. You can set up an AI to talk in your brand voice and use your branding colors and fonts and all that stuff to produce really high quality materials that look and sound like your brand automatically, that you just need to go in and edit them. You don't actually have to write from scratch. You have the AI write it, then you go in and you edit it and make sure it looks good. And again, some more examples on the next slide.
And then you have auto draft quotes. Obviously that needs some human oversight. A hallucinated spec still binds you. Quick story here. I was experimenting with a new AI model at the end of last year, early this year, and said, okay, create this quote. It was something a little bit abnormal, not our typical service. So I wanted to see what came out, and I approved it and said, go ahead. And it got sent to the customer. And then I used, we had another similar quote a few months ago. And so we went back and looked at that, and some of the language that we actually submitted as a proposal, and this is my fault, I did not read every single word, but it was like in the scope of work, it said, here's what we would do. And in this below that, it said, here's what we will not do. And in reading that, I was embarrassed. It was like, we will not babysit you as a customer. We will not. I mean, it didn't use that, but it was horrible. And I learned my lesson. You got to look, you have to have that, final inspection here. And I don't know if that's why we didn't win the bid or whatever, but it was just a section that I just overlooked with a few bullet points that, I wouldn't have been pumped if I was asking for a proposal and the prospect sent that to me. I wouldn't have liked that. So lesson learned there for us.
Yeah. So this is just, some examples of companies that are doing this right now. Continental over in Sumter has AI reading automaker spec sheets and routes each requirement. So this used to be engineers sitting down, reading specs, figuring out what decisions need to be made. It used to cost almost 40,000 hours per project. They cut that down by 80% using AI. And like James said, you need humans to own this work, because at the end of the day, a human has to be responsible but you don't need a human reading every line of every spec manual, right? You have the AI get it to 80%, and then the human takes it that last 20%, make sure everything looks clean and well. And then the beauty of custom AI systems versus more generic AI systems is they can do better, right? When you customize an AI system, it knows your brand, it knows your processes, it knows your methodologies, it knows what's important to you. And that leads to the AI being able to do more and more effectively. So let's go ahead and go to the next one. Okay, we won the quote. Thankfully, Wishbone is going to production. But before we go to production, we have to plan and schedule our production run. Forecasting demand. How much of this part are they going to need and when? Scheduling the line. When is this going to run? Inventory levels, like James mentioned earlier. How much product do we need? Like how much raw materials do we need? And when should we order those? And all of that kind of stuff. The planning and the scheduling is a huge piece of this. Let's go ahead. The issues, we're guessing at demand. Right? We don't know for sure. Scheduling is hard, especially if you're running a larger plant. If you have one line, scheduling is maybe not so hard. But if you have 5 lines and 10 products, now that gets to be a pretty tough problem. And then there's real monetary consequences on getting this stuff wrong. If you over forecast, you have cash trapped in inventory. If you under forecast, you're missing orders, and the client's not. You're not only are you leaving money on the table, but the client's not happy with you. So AI, this kind of demand forecasting, it's very, very good at. Like we said, AI is really a pattern recognizer. So seeing what have people demanded in the past, what do the market conditions for this product look like, how can we forecast demand so that we can plan our runs effectively. Schedule optimization is really just a math problem. I have this many things that each need to get produced by this target date, and I have this many places to produce them. What's the optimal way to put all this stuff together? Mm-hmm. Just a big math problem, the kind that AI is also very good at solving. And a better forecast means, better margins, less money being held in stock, more client satisfaction. It goes a long way here.
Yep. And any little piece that's off, like the AIM says here, forecast drifts, you got to monitor them or they'll quietly lie to you. Any little piece that's off, AI, it's like not putting your the right master down on a copy machine, and then you hit print 1,000 copies and you walk away. So you can very quickly replicate the wrong thing or scale inaccuracy. So that's where 9.1 and A628 comes in to play here for the standard.
That's a really great point. AI accelerates processes. It doesn't fix broken processes. If you have a process that's bad or something that's out of date and you use AI to accelerate it, you are now dealing with an accelerated number of problems.
That's right.
If you, and like James said, the forecasting is dynamic. Market conditions change, customer demand changes, your schedule and other products that you have to produce changes. So that's not something you run once at the start of the year and you're good for the next 2 years and you run based off of that. It needs to be updated regularly, which means it needs to be owned. I think we can skip. I mean, these are more examples like global foods manufacturer used AI just to illustrate what we did there. It's able to save real things. Okay. Procurement and supply chain. Here, we need to actually get the raw materials into our supply chain. Will the supplier deliver? What do lead times and pricing look like? Does the inventory live? AI can help with supplier risk scoring. It can compare contracts between different potential vendors who are supplying you. It can look at supply chain optimization to see, okay, when are we going to need materials? How are those materials going to get to us? Basically, it just helps you be more informed about your supply chain and procurement process, which leads to better results. The more you know about what's going on, the better you can coordinate everything. And AI can help that all along the way.
And A5, 4, and 9.2, auto scoring suppliers can bake in bias and make sure that the human oversight is there for the final decisions.
Yeah, absolutely. Okay, as we can see, again, some numbers here. McKinsey used some AI-driven supply chain forecasting to produce 65% availability. Inventory optimization on held over stock gets significantly reduced. So there's some real money in these as well. Let's keep it moving.
All right.
Oh yeah,
We'll,
wait. I think that's a great point there. That
yeah,
makes.
Yeah. Go ahead if you want to run with
Little
it.
games. No. The no published ROI is a real potential result.
Right. Yeah. It's an honest answer versus guessing. So yeah, just be able to meet your claims, and if it hasn't been validated yet, if it's projected to save $1 million, make sure it's explicit that using our new AI model. Well, we assume this, but we haven't validated it yet. Just making sure that you can meet your claims, especially if you're in a contract state between either yourself and as the supplier to your customer, or between you and your supplier.
Okay, fun part. We're producing. We got the quote. We've got the plan. We've got the raw materials. Now we need to actually produce it. Welding, looking at part quality, machine uptime, all that good stuff. Next slide. So what are some issues? In-process errors and scrap when things go wrong. Unplanned downtime, machines breaking. Maintenance, knowing what to maintain, how to maintain these machines. Knowledge gaps and tribal knowledge and veterans walking out the door, leading to issues in your current operations. And then how can AI help? So many ways. In-process controls and corrections. You can have vision guides that watch things getting produced and saying, oh, this is getting produced wrong. You can do predictive maintenance, having the AI hook up to sensors on the machine to see how the machine is working. Is there any wear? When will we need to replace parts? Having chatbots that are grounded in expert knowledge to answer questions on the fly, right? If you have these hooked up to SOPs and hooked up to, different knowledge sources of that have the process contained within. If you have a question on the process, you just ask the AI system. It pulls the relevant document, answers your question according to your documentation instead of just making something up. Also, safety. It's not even on this slide. AI can monitor safety, right? You can have PPE detection. Are people being safe? Helping reduce OSHA violations, all that kind of stuff.
Yep. Just making sure, just like 20 years ago when you decided to put an in-process inspection camera versus having humans, and you'll see that in a couple slides repeated here, but you got to make sure that you can trust that system and put in safeguards and constantly validating, logging, in automotive, it's measurement system analysis. How trustworthy is this new tool that you're putting in the work stream?
Absolutely. And this has been shown to be really, fruitful across a lot of things. BMW Spartanburg, we'll mention them again in a minute here. They have a laser guided by AI that corrects misplaced welded studs in process, saving $1 million a year. There's a company that is unnamed, AI testbed failure prediction, 90% fewer testbed failures. You can hook AI up as a camera system. I know Ruggable, if anybody knows them, they have an AI that watches the rugs post-production on their way to shipping out to the customers to make sure that the product that they're shipping lines up with the order that was placed. They're actually shipping the right patterned stuff to the right people, vastly reducing the costs of returns and things like that. You can have cameras watch bottles on a line to look for defects. If you have a bottling line that runs at 100 bottles a second, you can't watch that with human eyes, but you can have a camera synced up to that frame rate, checking every single bottle for defects. The uses here are really endless.
Yep. And this is just saying redeployed of your workers is not replacement. But what it brings up is the competency question. Are those human resources going to a place and are they competent in that new role? That's more of the 9001 side. But here on this particular standard 42001, it's 7.2. If you're now bringing in that new tool, is the AI agent competent at being able to decipher good from bad?
Yeah. Yeah, and these validations, obviously, we're not talking much about process of how these AI tools are built and developed here, but that's a big piece of it, right?
Mhm.
Most of the work we do building custom systems is that validation piece. It takes a week to build the system and then 3 weeks to validate it and make sure it's working properly, because that's where the cost is. If you have a system you think works and then you put it in production and it doesn't, that could be a very costly mistake.
Mhm.
Little bonus, I said we were going to come back to BMW Spartanburg. This is what everybody thinks of when they think about AI in manufacturing, or at least out of the folks I've met. They want to talk about robots walking around factory floors, taking over jobs. And then the question I always get is this realistic? It's a mixed bag. So BMW Spartanburg last year, not this year, last year, did a pilot of humanoid robots in their plant. First BMW plant in the world, right here in our backyard, James.
Mhm.
And this was very interesting. Basically, they had thousands of these robots, or even maybe it was a few hundred to a couple thousand robots. No, it was only a few hundred robots that were working on the line, moving parts around, placing parts in different places. You can see this particular robot in the bottom corner is putting a part on a welding fixture to get a part welded. And it worked quite well. 90,000 plus parts moved, 1,200 hours. They ran in 10-hour shifts. And the initial results, they haven't released too many official findings from this study, but the unverified reports are that this worked really well. 40% lower cost than would have been done otherwise, 99% accuracy. Yeah, this was only a trial though. This was ran for 1 week, and the main purpose was to collect data and test, is this a reasonable thing to do in this type of system? This is not meant as a replacement. And what we're seeing more and more from humanoid robotics over the past year is these systems are getting a lot better and a lot cheaper. Humanoid robotics out of China are very cheap. It used to be, a humanoid robot like this would cost $100,000. You could get one for 10 now from China.
Wow, that's amazing.
10,000, yeah. And then they're so cheap that the U.S. actually just placed a ban on Unitree, disallowing the import of these robots into the U.S. from China, literally just a couple weeks ago. The reason they placed that ban, or the alleged reason, we can argue about what the real reason is. The alleged reason is all about safety, right? How do you know what this machine is doing? How do you know where the data is going? How do you know that it's going to be safe and not make a mistake or drop a heavy piece of metal onto somebody? So the actual accuracy and ability of these humanoid robots to perform actions is still subpar where they need to be right now. The price is coming down. The software is coming up in terms of quality, but I'm not expecting to see these particularly prevalent for the next 5 years, 5 to 10 years. I expect to really see this being an option. And a quick aside here, robotics has been prevalent in manufacturing for a long time now. Humanoid robotics is a bit of a different animal. And so the question is, why would we go with humanoid robots when I have a perfectly good robot arm that can just do my task for this spot in the line? And that's been a reliable piece of technology that we've seen for a decade now. And the answer is flexibility. Human infrastructure and buildings and environments are set up for humans, 2 legs, 2 arms, being able to reach stuff. Usually when you bring a robot arm in, you have to design the enclosure specifically for that robot so it knows where things are and can move things around, which means it can do one step in one process really well. But if you have to change that step or change that process or deploy that robot to a new task, that can be a very expensive change. Humanoid robots allow flexibility. You can just drop the robot into whatever spot a human was working in, and it can do all the same stuff. You don't need to adjust anything. So that is the motivation for these humanoids over those kind of static robot arms.
Yep. And then a little comment here: is the number real and demonstrable? And how do you verify accuracy? And even if there's 1%, if you're talking about parts per million or parts per billion, that 1% inaccuracy is pretty big. So just like with a human, what controls are there to detect any slippage? You need to really mind that same variable, that same operational condition, with the integration of robots and other machines.
And one other piece when it comes to measuring numbers and accuracy of these systems that I think is really important to keep in mind is that usually when we're implementing AI, we're trying to make a process more efficient. We're not trying to make it perfect. So AI systems don't really reach 100% perfection usually. There's always going to be some error rate in there. The goal is when you measure that error rate, you have to compare it to what's happening right now. It's not how this isn't perfect, which means we can't use it. It's what are we doing right now and how much does this improve us? That is the real measure. So would you rather go from a human making one mistake in every 10 runs to an AI system making one mistake in every 20 runs? I don't know. Maybe that is an improvement, but maybe it's less accountable. These are all decisions that have to be thought through carefully. But just when it comes to validating AI systems, there is this big myth going around that, these systems have to be perfect or they can be super accurate. And that's not always the case. We're not always aiming for perfection or super high levels of accuracy. We're aiming for improvement. And that's the goal and the target. And everybody going into an AI project should have that set in their mind very clearly. Quality and inspection. Obviously, we talked a little bit about this when I mentioned Ruggable doing that quality inspection, but are things being built to spec? Are things being reproducible? Do we have things drifting out of spec? Are we sending the right things to the right people? Can we catch mistakes before they ship? All good questions. Manual inspection can be slow and inconsistent that, somebody comes in and they've had a bad day in their personal life. That could affect their work. That doesn't happen to an AI. Usually it's done sampling and usually after the fact, you print a batch of 1,000 and then you take one and you go and measure it. And if it's good, great. And if it's not, you throw out the batch of 1,000. AI systems can check every single one as they come off the line. So that if there's an error, you stop and you fix it and you're not getting all that scrap. And these systems have been around for a very long time.
Yep. And again, you're magnifying or amplifying an incorrect status of, are they false positive, false negative, so on and so forth. So what is your fallback in 6.12 and 8.7.4 address that?
Yeah, fallbacks are pretty important. I mean, what happens if the AI system goes down? Does the line stop, or do you have a human go in and do the inspections? It's something worth thinking about. And yeah, I mean, this is just again some statistics here. Audi inspects every weld using AI on their cars, 99.7% accurate versus 80% human accuracy. Again, it's not 100%. There is some issues there, significantly better than people are. And yeah, just all other stuff. This is a really common use case.
We've got about 5 minutes, Jack, just to let you know.
Sure. We can always just call it here and move into discussion, but I think these are the last set of slides.
Yeah, this is the last step in the workflow here.
Customer monitoring and support. Again, monitoring performance, handling warranty, supporting the customer, learning how to improve the product from the customer feedback. Field failures often surface detections too late. Warranties bleed your margin away. Oftentimes, manufacturing doesn't even have a feedback loop, really. The customer service support there is to absorb customer feedback, not to leverage that to improve product and engineering. AI can help fix those. Predictive monitoring on telemetry, warranty patterns of warranty claims to understand what is causing warranty claims and how that can be fixed, looking at root cause analysis, recording customer calls and analyzing what's going on there. Are there any common themes or patterns that we can address? So using AI can really, in this case, just aggregate those big sets of data and help extract meaningful insights from them. And then we don't need to go through, again, more numbers supporting these kinds of use cases. I think that's it. I think we stop there. And we
Okay.
leave it up to any questions or discussion that we have there. Like I said, I didn't think we'd have time for the demo.
Yeah, it's that's okay. But yeah, we'll share this slide deck so you can have a little bit different context. But this is more of a workshop and intended to be more than just a 1 hour lunch and learn. The last slide here, Jack, in summary, like how do they get to know you? How do they reach out? People watching this, if they want to connect with you, what's the best way to do that?
Sure, yeah. I think we mentioned this earlier, but I didn't talk much about it. I run Tidal AI, local Charleston-based AI consulting firm. So we build custom AI systems. We do AI strategy, helping businesses figure out where AI can fit in their system. We do workforce training to help get employees up to kind of baseline competency with things like ChatGPT and Claude, as well as one-on-one coaching for folks more at an executive level to help them personally guide them through AI usage. And if you want to get in touch with me, I'm on Circle in the Concentric community. You can reach out there. You can shoot me an email. My email is right on screen there. You can go to the website. You can call James and tell him to give you my phone number. Plenty of options.
Yeah, you're on LinkedIn too, so they can
I'm on
find you that.
LinkedIn. Yeah, I'm all over the place.
And I would say one of the places I see, Jack really adding value, and I hope that the market is more responsive here. It's on this piece. Let's be strategic about how we're using AI, and it's okay to have pilots in certain, work cells or certain parts of that work process flow or that value stream. But start here, start at a high level. Start with deliberately using AI, and instead of letting everybody just kind of, Wild West test this stuff out. And this is where I think Jack, beyond the tactical stuff, can really help, especially as we're going into a new year, maybe baking an AI strategy into your annual operating plan for 2027, or your budget for 2027. He's a great resource to use at that part of your business. When it comes to 42,001, we have a certification course that we're just launching. We have the web version, we have the mobile version. So if you have any interest in this, it is an Exemplar Global certified course. We are finishing up this week our comments from our beta testers, and ready to rock and roll. So you can scan this QR code if you have any interest in kind of checking that out. But you can see kind of down in here, what is the mobile experience? What's the web experience look like? What's the mobile experience look like? This is a self-paced course, and you have access to the instructor for questions and comments and that sort of thing. And then finally, if you're interested in joining the community, and Jack talked a little bit about this, you can find more about joining the community down here with this QR code. Our full course listing is here. And then this again is your access link to the AIMS or 42,001 Exemplar Global certified course. So, and we got one other little piece here, which is AIM saying, hey, don't forget about me. Thank you. AIM says thank you. We thank you for your time. From Tidal AI, Jack, thanks so much. We really appreciate you taking the time and educating us and partnering on this lunch and learn. So be well. And thank you, everyone. If you have additional questions, reach out, or you can ask the questions on the community. The posting of the recording should be up on acommoncenter.com within the next hour. So, Jack.
All right.
Everyone else,
thanks, y'all.
Thanks for joining.
Thanks a lot. Great stuff.
Thanks so much.
Thank you.
Thanks, guys.